This is a really quick review of what it means to be a Bronsted-Lowry acid and base. And this problem is asking us to indicate all the Bronsted-Lowry acids in the following chemical reaction, where hydrochloric acid reacts with water to form hydronium and a chloride ion. So I'll just write out the definition of what it means to be a Bronsted-Lowry acid. So what this means is that to be an acid, you have to be able to donate a hydrogen ion. So that's the biggest part of this definition, and this is different from a base. A base accepts that hydrogen ion that the acid donates. So looking at our reactants, we have hydrochloric acid and water. Water can act as a base or an acid, but in this case, hydrochloric acid is a strong acid and has this hydrogen that can easily become a hydrogen ion to donate to this water molecule. So just by looking at this, we know that hydrochloric acid is a Bronsted-Lowry acid. It will donate that hydrogen ion. So I'm going to call this acid 1. And I'm also going to go over a little bit about how to determine conjugate pairs. So this is our acid 1. We know that water is acting as a base in this scenario, so this is going to be our base 2. And so starting with hydrochloric acid, our first acid, that has a conjugate base. And the conjugate base is formed when this hydrogen ion is donated and we're left with a chloride ion. So this is actually the conjugate base of hydrochloric acid. So I'm going to call this base 1. And this is just to show you that acid 1 and base 1 form a conjugate pair. And in the same way, our base, which is water, has a conjugate acid, which is formed when our base accepts this hydrogen ion from our hydrochloric acid. And this forms hydronium, which is shown here. So this is our acid 2. And again, this is just to show that these are conjugate pairs and these are conjugate pairs. So when we're finding our Bronsted-Lowry acid, we're looking at our conjugate acids as well. So the answer to this is that hydrochloric acid is a Bronsted-Lowry acid, and additionally, hydronium in this case is also a Bronsted-Lowry acid.